we want to compare these two types of situation and then understand how to solve them and how to use them in tough questions or how to apply them when we see tougher questions. Now this part is having a raised power 2 equals 4 and this is 2 raised power a equals 4. So this is a variable holding a number and this is a number holding a variable. So we're looking at how does this actually, what is this talking about? What do we have to know in order to balance indices? So the first thing we have to look at is how do we solve this part? When we have an alphabet, holding a number, the best thing we can do is multiply this by the inverse on this side and do the same here on this side. So the inverse of 2 is 1 over 2, so you multiply them by 2, you can cancel them out. And so we have this out. Then we're left with a raised power 1 equals. So this is 4 raised power 1 over 2, which can also be a square root of 4, and then leaving 1 outside also. So this is a, and the square root of 4 is 2. So this is how this is work. This is how this is done. Looking at that. Now there's a different thing here. Looking at this other part where you have 2 raised by a equals 4. Now there's a system here. We have to balance this. Yes, we have to make this part look like this part. So the values of 2 that will give us 4. We know 2 times 2 is 4. Now I want to make it like, yes, have raising to the power. So 2 multiplied 2, that's 2 times, that's raised by 2. So 2 appears twice, that's raised by 2 gives 4. That is 2 raised by 2. So the difference between this and this is balancing this part, which is the 2 raised by a equals 4. And then you balance it here. So 2 cancels 2 and a equals 2. This is a very important part of indices where student needs to know how to apply these both scenarios. When an alphabet holds a number, you should always go with the what inverse, multiply by the inverse of that number on both sides. That's the inverse of 2 here is 1 over 2. And then when a number has an alphabet as its power, you have to balance both sides. You get a number that looks like this but has to represent what this alphabet holds. So 2 times 2 gives us 4, that's 2 raised by 2. And then we have this. Now let's consider another example. We're looking at this same thing here. Let's consider an example. Okay. Alright, let's assume we have something like this. Now let's consider another example. Now we're looking at let's say we have something like this. X raised power 1 over 2 equals 6. And also we are looking at let's check this. Okay, x raised power 1 over 2 equals 6. Now what we've learned for the on the other side, we notice that we can also multiply both sides by the inverse. So the inverse of 1 over 2 can also be written as 2, or you say 2 over 1 if you want. And you have 6 2 over 1. And this cancels this. Automatically you have x raised by 1 equals 6 raised by 2 over 1, which is the same thing as 2. So x equals 36. Alright, now we've applied this on another level. Let's consider also the other part which we learned, where we have something like this. We're looking at 7 raised by x equals 49. Same thing, the same method. So we also have to balance this 7 raised by x, and then want this part to look like 7 raised by x. Now we understand that 7 raised by x equals 49. 49 has to be what? The value of 7 that will give 49, that is 7 times 7, and which is 49. So 7 multiplying itself twice, which is 7 raised by 2. And so we'll cancel this part, and x is equals to. So we'll look at another question again. We are looking at this. Now let's take a more complicated question, kind of. We're looking at 3 raised to power c minus 1 equals 81. Now we understand that if a number is having an alphabet as its power, you have to balance both sides. So this is more like also what we've been doing before. Considering what we have here, this is 3, and also we have 81. So we're looking for a number that could balance both. We know 3 is raising the power of c raised to power minus 1 and equals 81. Then since you have 81 there, the value of 3 that can give 81, we can say 3 times 3 times 3 times 3. So we know that's 3 times 3, 9. 9 times 3, 27. 27 times 3, that's 81. So that is 3 raised to power 4. So in order for us to balance this, we can say 3c raised to power minus 1 equals 3 raised to power 4. Good. And so we have this cancels this. C minus 1 equals 4. Automatically, C equals 5. Now let's also consider another part. Let's look at this question we have. So let's consider another question that has to do with this. Look at 2 arrow and then the power of 3 over 2 equals 54. Now if you look at this, it is quite confusing, but you have to start with 2 holding a variable and then 2 multiplying a variable, and the variable is holding a power, and then you have 54. So first thing you have to consider is you're trying to make this variable a single value. That is the subject of the formula. So considering this, you also have to divide by 2. You can start by dividing by 2. And so you divide by 2. Then you have this 3 over 2 equals, and this becomes 27. From the last part, I explained that when an alphabet holds numbers, you have to multiply both sides by the inverse, and then you have this, then arrow 3 over 2 times 2 over 3 equals 27, 2 over 3. So automatically you have multiplied both sides by the inverse. So this cancels this cancels this, and arrow is left alone. It's a free man. So you have this, and you understand that if you have 27, 2 over 3, so it automatically means that 3 can actually give a cube root, leaving 2 outside. So we take 3 down this point, and then we have cube root of 27, and in bracket 2 outside. So r becomes, the cube root of 27 is 3. That's 3 times 3 times 3. So that is 3 raised to the power of 2. The answer is 9. So questions like this, you also need to apply the rules of indices here. After dividing by 2, you need to apply, like I said, multiply both sides by the inverse, and you would actually arrive in the same part you've been arriving from the first part that I explained. Now let's consider another question. We're looking at 5 raised to the power x plus 3 equals 1. So most often times, students always say, how do we balance this type? You have 5 raised to the power x plus 3 equals 1. And so it's, you don't have a value you can say you're multiplying to give the actual value you have here. But we can actually still balance it. We understand that in maths, 5 raised to the power 0 can also give us 1, basically. So in order for us to balance it, we can pick a number. 5 raised to the power 0 equals 1. So do the same thing here. That is going to be x plus 3 equals 5 raised to 0. Yes, balance that. So now that we've balanced it, we cancel on both sides. And then we have x plus 3 equals 0. So definitely x becomes 0 minus 3, which gives minus 3. Alright, let's take a more complicated question. And relatively to what we have, we're also going to look at. Now, with what we've learned, we want to take something more advanced. And we are looking at, okay, from JAMB, a question like this, 5 raised to power 2, then we have parentheses, x minus 1 times 5, then we have raised to power x plus 1 equals 0.04. So before I continue, I would like to throw light on this 0.04. We understand that 0.04 can also be written as, okay, I always use a layman system to understand this. I could say my point represents 1 and the other numbers represent 0. So I pick the whole number there, and that's 4 over 100. So this is what I mean, 4 over 100. So this number can also be written as 5 is equal to x minus 1 times 5x plus 1 equals 4 over 100. Now, you know, before we could cancel any values of 5 or anything, we have to balance this equation. So I'm going to bracket this, yes, to make it look well enclosed. Alright, so 4 over 100 can also be 1 and 25. So this is going to be 5, 2, that's x minus 1 times 5 in brackets x plus 1 equals 1 over 25. Now returning back to indices, 1 over 25 can also be 1 over 5 square. And since this is an inverse, we can also write it as 5 raised to the power minus 2. 5 raised to the power minus 2 can also be 1 over 5 raised to the power 2. So we're balancing this equation here. So we're balancing this equation here. And we're going to have 5 and 2 enter into the bracket, 2x minus 1 minus 2, sorry, times 5x plus 1 equals 5 raised to the power minus 2. So now we can collect like terms in according to indices. We have like terms in the indical part, that is having a raised to the power m times a raised to the power n, can also be a raised to the power m plus n, because they are similar values here. And the same thing we have here, 5 and 5. So let's make it 1. We're going to have 5. The multiplication here showing that our index values will be added. So we can still put this in a bracket. And we have x plus 1. So what am I putting in the bracket? In case we have a negative number, a negative sign, sorry, we can actually, the negative sign will actually multiply through the bracket when we're expanding. So the positive number, positive sign also expand through the system. And for us to continue this, we can decide to cancel. Then we cancel 5 each. And so we have 2x minus 2. Now this is already a positive value, so this is going to be plus x plus 1 equals minus 2. Now let's collect like terms. So collect like terms, we have 2x, and then we have have plus x, and so we have minus 2, then have plus 1 equals minus 2. So this becomes 3x minus 2 plus 1, that's minus 1 equals minus 2. So we have this going to be 3x equals minus 2 plus 1, and then we have 3x equals minus 1, and so we divide both sides by 3. Automatically x equals minus 1 over 3. So that is all for this part. In our next class, we'll be doing broader questions, taking more questions from examination, past questions, and trying more tougher ones. Thank you very much for joining us.